Neptune is the most mysterious planet in our solar system, and we've only visited it once. There is a planet at the edge of our solar system that we have visited exactly once. One single spacecraft, one single flyby, 989 days of travel to get there, and just a few hours to observe it before the darkness swallowed it again. That was 1989. We have never been back. Everything we know about Neptune, the eighth planet, the farthest world in our solar system, comes almost entirely from those few hours. And what we saw in that brief window raised more questions than it answered. Neptune is not just distant, it is deeply, genuinely strange. And the more scientists study it from afar, the less they feel they understand it. This is the story of the planet we barely know. Neptune's discovery alone is one of the most extraordinary stories in the history of science. We didn't find it by looking at the sky. We found it by doing math. In the early 1800s, astronomers had already discovered Uranus, the seventh planet. But something was wrong. Uranus wasn't moving the way it should. Its orbit kept deviating from the predictions, slightly but consistently, as if something massive and invisible was pulling on it from the darkness beyond. Two mathematicians, Urbain Le Verrier in France and John Couch Adams in England, independently decided to calculate where that invisible object had to be based purely on the gravitational disturbance it was causing. No telescope, no observation, just mathematics. In 1846, Le Verrier sent his calculations to the Berlin Observatory. Astronomer Johann Galle pointed his telescope at the exact coordinates the math predicted. Neptune was there, within 1 degree of the predicted position. It was the first planet ever discovered by mathematical prediction alone. Before anyone had seen it, mathematics knew it existed. Mathematics knew where it was. That moment changed how science understood its own power, and Neptune has been surprising us ever since. For 143 years after its discovery, Neptune remained a blur in our telescopes, a pale blue dot at the edge of everything, too far for any meaningful observation. Then, on August 25, 1989, Voyager 2 arrived. It had been traveling since 1977, 12 years, nearly 5 billion kilometers, and it had only hours to observe. A planet the size of nearly 60 Earths before its trajectory carried it away forever. What it found stunned everyone. Neptune was alive, not literally, but in every scientific sense that matters. For a planet so far from the Sun, receiving 900 times less sunlight than Earth, it should have been cold, still, and geologically dead. Instead, Voyager 2 found the most violent weather in the solar system. Winds on Neptune reached 2,100 kilometers per hour. That is faster than the speed of sound on Earth, faster than any wind ever recorded anywhere in the solar system. On a planet that receives almost no energy from the sun, nobody expected this, nobody had predicted it. And to this day, nobody fully understands where that energy comes from. Voyager 2 also discovered something else. A massive storm system in Neptune's southern hemisphere. A dark oval vortex the size of Earth itself. They called it the Great Dark Spot. Similar in structure to Jupiter's Great Red Spot, but far more intense. When the Hubble Space Telescope looked at Neptune 5 years later, the Great Dark Spot was gone, completely vanished, replaced by a new storm system in a completely different location. Neptune's weather doesn't just change, it transforms entirely. on timescales that make our own climate look permanent. Neptune belongs to a category of planets called ice giants, a classification that is both accurate and deeply misleading. When scientists say ice, they don't mean frozen water floating in space. They mean a superheated mixture of water, ammonia, and methane, compressed under pressures so extreme that the materials behave in ways that have no equivalent on Earth. At Neptune's core, under pressures millions of times greater than Earth's atmosphere, scientists believe something extraordinary happens to that mixture. The carbon atoms in the methane get stripped from their molecular bonds, squeezed, compressed, and under those conditions, carbon doesn't stay as gas or liquid. It crystallizes into diamonds. Current models suggest that deep inside Neptune and its twin Uranus, it may literally rain diamonds. Diamond crystals forming under pressure, falling through layers of compressed fluid, accumulating at the core in a sea of liquid diamond. We have partially replicated this in laboratories using lasers to compress carbon under extreme pressure. The diamonds form, the physics works. Inside Neptune right now, there may be more diamonds than exist anywhere else in our solar system combined, and we have never been close enough to confirm it. Neptune has 16 known moons, but one of them is unlike anything else in our solar system: Triton. Triton is the only large moon in the solar system that orbits its planet backwards. Every other major moon orbits in the same direction its planet rotates. Triton orbits in the opposite direction, what astronomers call a retrograde orbit. This is not a small anomaly. It is a fundamental violation of how moons form. Moons that form alongside their planets always orbit in the same direction, always. The physics of formation makes any other outcome essentially impossible, which means Triton didn't form alongside Neptune. It came from somewhere else. The leading scientific explanation is that Triton was once a free object in the Kuiper Belt, the vast region of icy bodies beyond Neptune, that wandered too close and was captured by Neptune's gravity billions of years ago. That capture event would have been catastrophic. The gravitational stress of being captured into orbit would have generated enough heat to melt Triton entirely. It would have been a liquid ocean world for hundreds of millions of years before cooling into the frozen surface we see today. And here's what makes Triton genuinely unsettling. Its retrograde orbit is slowly decaying. Every orbit brings it slightly closer to Neptune. In approximately 3.6 billion years, Triton will cross what's called the Roche limit, the distance at which Neptune's tidal forces will overcome Triton's own gravity and tear it apart. Neptune will destroy its own moon, shred it into a ring system that will make Saturn's rings look modest. We are watching the slow-motion countdown to that destruction right now. Every single day. Here's what humbles me most about Neptune. We have one dataset, one visit, a few hours of observation from 35 years ago, with technology that, by today's standards, was primitive. And from that single glimpse, we discovered supersonic winds with no known energy source, weather systems that appear and vanish completely, the possibility of diamond rain at its core, and a captured moon slowly spiraling toward its own destruction. One visit, a few hours, and already the planet broke multiple assumptions scientists had about how worlds work. We have no idea what a longer look would reveal. NASA has proposed a Neptune orbiter mission, a spacecraft that would spend years in orbit around Neptune rather than hours flying past it. The science community has ranked it among the highest priority missions for the next decade. But it hasn't launched. Funding, complexity, and the sheer distance, nearly 5 billion kilometers, make it one of the most challenging missions ever proposed. If it launches in the 2030s, it won't arrive until the 2040s. Neptune has been waiting for us for 35 years. It will wait a little longer. I think about Neptune differently than I think about other planets. Mars we've covered in rovers. Venus we've sent dozens of probes to. Jupiter and Saturn have had dedicated orbiters studying them for years. Neptune we visited once, briefly. By accident almost, Voyager 2 was heading out of the solar system anyway, and Neptune happened to be in the right place. And in those few accidental hours, the planet handed us mysteries that have occupied scientists for 35 years and still have no complete answers. What does that say about what's waiting for us if we actually go back? What does it say about every other planet, every other moon, every other world? In this solar system we've only glimpsed from a distance. We live in a solar system of 8 planets. We have meaningfully explored a fraction of one of them. The rest is still out there, still turning, still hiding whatever it hides, still waiting for someone to come close enough to ask the right questions. If Neptune can surprise us this much from a single flyby, imagine what the outer solar system is still hiding. Follow Hidden Cosmos, because we're just getting started.